Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Perimeter and area. This video will help you understand perimeter, understand area, and use formulas to find area. Understand perimeter. Let's start with the definition. The perimeter of any figure is the distance around the figure. To find the perimeter of a figure, we could wrap a string along the outside of the figure. The perimeter of the figure will be the length of the string. And you can see here that we've got this figure, and we've wrapped the string around it, and each of the sides has a length. And so to find the perimeter, all we would have to do is add up the length of each of the sides, which would in the end be the length of that string. So in this case, if we added all these lengths up, 5 feet, 2 feet, 4 feet, and 7 feet, we end up with a perimeter of this figure of 18 feet. Now let's take a look at an example that will help you understand how to find the perimeter of a figure. Example 1. Find the perimeter of this figure. Well, we have a figure here. It looks like it's kind of made up of some rectangles. To find the perimeter, we're going to need to know all of the sides. And you can see currently we don't know some of these sides. This large side down here on the bottom is still a mystery. And over here on the right, this small side is still kind of a mystery. So before we can find the perimeter of this figure, we're going to have to find the lengths of these sides. Let's start with the one down at the bottom. Well, if we draw a line and kind of separate these two rectangles here, we know that this distance has got to be the same as the top. So since in this rectangle this distance was 6 feet, if we come straight down and we brought that line straight down, this distance is going to have to be 6 feet. We can do the same thing with this distance of 4 feet here. If we bring that distance straight down, this side here is also going to have to be 4 feet. Then, which makes this whole entire bottom side 10 feet in length. So that's one of our sides. Now we need to find the other side over here. So coming over here on the right, that's the other side we're looking for. Well, let's go ahead and draw a line across here. And now we know that this distance all the way over here on the left side has to be 4 feet. Well, we know that this distance right here, from here to here, has got to be 3 feet. Well, this mystery feet here, this mystery measurement, plus 3 feet is going to have to equal 4 feet. So that makes this 1 foot. Now we know all the lengths of these sides. Now we can find the perimeter. So we use capital P for perimeter. I'm going to start up here at the top and work my way around the figure. So starting with that 6 feet, I have 6, and then plus 3, plus 4, plus 1, plus 10, plus 4. Now I just want to add these things together. So let's see. 6 and 3 is going to give me 9. 9 plus 4 is going to give me 13. 13 plus 1 is 14. 14 plus 10 is 24. 24 plus 4 is 28. So this figure has a perimeter of 28 feet. Now it's time to check your understanding finding the perimeter of a figure. Pause your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. Find the perimeter of this figure. Well, before we can find the perimeter, we're going to have to find the lengths of some missing sides. So you can see that we're missing this side length right here, and we're missing this big side length on the top right there. So we need to find those distances, or those lengths of those sides first. Let's start over here on the left. Well, let's see. The distance all the way across on this side, they tell us that that is 8 feet. Okay, so the distance kind of most of the way across, or most of the way up here on this other side here, is 5 feet. And so this little distance, if we draw a line across here, and it already looks like there's kind of a little white line drawn in there, but if we draw a line across there, that means up to there is 5 feet. The whole thing all the way has to be 8 feet. So what we can do is basically we can take the 8 minus the 5 to tell us what's left over on this side, which is 3 feet. So this mystery side length here is going to be 3 feet Now let's take a look at the top. Again, let's draw this so we get our two rectangles here. We know this distance here is 4 feet because it's the opposite side of this rectangle. And the opposite side of this rectangle, coming right up here, is going to have to be 6 feet. So altogether then, this is going to have to equal 4 feet plus 6 feet, or 10 feet. Okay, now we found those missing side lengths. We can find the perimeter. We'll start right here with the 8 feet. So we have 8, working around the figure, go clockwise here. Then we have 6, then we have 5, then 4, then 3, then finally when we get to the top we had 10 feet. So we're going to add this all together. Let's see, if we add the 8 and the 6 together, that's going to give us 14. 14 plus 5 is going to give us 19. 19 plus 4 would give us 23. 23 plus 3 would give us 26. And then, oops, got a plus sign there. 26 plus 10 would give us 36. So the perimeter of this figure is 36 feet. Understand area. Let's start with a definition. Area measures how much surface that a figure covers. Area is measured in square units or units squared. For example, first thing we have here is a picture of 1 square foot, which means we have a square that is 1 foot on each of the sides. The way that I would describe the area of this square foot, we could write capital A for area is equal to 1 foot squared. That's the shorthand way of writing it. We also could have written out the words square feet or square foot. Let's take a look over here at a square yard. And so a square yard means we have a square that is 1 yard by 1 yard. And again, if we want to describe that area, we would say the area of this square is 1 yard squared, or we could have again written in words just like we have up here, 1 square yard. In the following figure, a grid of squares that are 1 centimeter by 1 centimeter is drawn over the triangle. Since the triangle covers 8 squares, the triangle's area is 8 centimeters squared, or we could say it's 8 square centimeters. Let's take a look at this triangle. We've drawn this grid of squares over this triangle here. And now one way that we can find the area is just to count up the number of square units that this triangle covers. So let's take a look. We have 1, 2, 3, 4, 5, 6 full squares. So at that point we're looking at 6 square centimeters. Now if we take and look here at this is half a square here. We have half a square here and half a square here covered by the triangle. So altogether that's 1 more full square. So that would be 7. And then if I take a look here, I have half a 1 and half a 1, and 2 halves together will make 8. So the area of this triangle, since it covers 8 square centimeters, we could write 8 square centimeters, or the easier way to write that is, as described before, is just 8 centimeters to the 2nd power, and that means square centimeters. Now, typically we don't draw a grid of squares to find the area of figures, but this gives you an understanding of what we're finding when we're finding area, and that's why it's really important that we put all of our answers in square units, because when we measure area we're actually measuring with squares. Typically when we try to find the area of a triangle, we usually just use a formula because it would save us time. As I just mentioned, we usually use formulas to find the area of figures. And here you can see we have some formulas for the areas of a rectangle and a triangle. Let's first take a look at the area of a rectangle. To find the area of a rectangle, we multiply the length times the width. And here's the formula here. This is the way you usually will see this. Capital A for area equals L for length times W for width. And you can see down here in our picture that the length goes all the way across the bottom and the width goes up and down on the side. Now, it doesn't matter if we interchange these measures, the length and width. We could have said that the bottom of this rectangle was the width and the side was the length. It won't make a difference, and it certainly won't make a difference when we're trying to find the area of a rectangle. Now let's take a look at the formula for the area of a triangle. To find the area of a triangle, we take 1/2 times the base times the height. And so here's how you normally would see that formula. Capital A for area equals 1/2 of the base times the height. And if we take a look at our picture here, we have the base going across the bottom and the height going up and down. Now, one thing to note here is that to use the formula for a triangle, the base and height must make a 90-degree angle. And you can see here we have this noted or measured there that this is a 90-degree angle. And that is because when we measure the height of something, we always want to measure straight up and down, which means we want to measure perpendicular to the base. If they had given us a measure right here on the side of the triangle, for this edge here, we wouldn't use that measure to calculate the height or to use that to find the height. We want to make sure when we're measuring height, we're going straight up and down or perpendicular to the base. Now let's take a look at some examples that will help you understand how to find the area of triangles and rectangles. Example 2. Find the area of the triangle. So here we have a triangle, and it looks like the height of this triangle is 6 yards and the base of this triangle is 8 yards. Now, the base doesn't necessarily mean bottom. It just means the side that we have that is perpendicular to the height. And so that 8 yards is going to be our base. All we have to do now is write down the formula. 1/2 base times height. And now let's plug that information in. So I'm going to have 1/2 times the base, which was 8, times the height, which was 6. Let's go ahead and finish this multiplication out. 1/2 times 8. If I take 1/2 times 8, all I'm really going to be doing is finding 1/2 of 8. Well, 1/2 of 8 is 4. And so then I'm going to have 4 times 6. Let's finish up over here. So 4 times 6 is 24. Now I don't want to stop right there because I want to make sure that I'm indicating this is a measure of area. Notice we were using yards over here. So this is going to be 24 square yards, meaning this triangle, if I was to draw a grid of squares, this triangle would cover 24 of those squares that are 1 yard by 1 yard. Example 3. Find the area of the entire figure by adding the areas of the two figures that make it up. Well, you can see on the top here we have a triangle, so I'm going to have to find the area of that triangle. And in the bottom I have an area of a rectangle. Let's start with finding the area of that rectangle. So the area of the rectangle is length times width. In this case the length is 30 and the width is 10. So the area of that rectangle is 300. In this case, since we're measuring with feet, it's 300 square feet. Now we need to find the area of that triangle, but it looks like we've got some information missing. In our triangle there, draw a little sketch of it. The base of that triangle is actually 30 feet because that has to match the bottom. This measure here was 30 feet, so that if we go straight up in that rectangle, that makes the bottom of that triangle 30 feet. Now we need to find the height though, so we're looking for this height of this triangle. We're going to have to do some work over here on the left. Notice this whole distance here is 30 feet. And if we take this distance here, from here to here, that's 10 feet. That must mean the height here, from here to here, has to be 20 feet. So the height of that triangle then is 20 feet. Now let's use that information to find the area. Formula again is 1/2 base times height. And so we would say 1/2. The base in this case is 30. The height was 20. If I take 1/2 of 30, I'm going to get 15. And so I need to multiply 15 times 20. Let's come over on some scratch work over here, and we'll multiply 15 times 20. We're going to multiply by 0. We'll get 2 zeros. 2 times 5 is 10. Carry the 1. 2 times 1 is 2 plus 1 is 3. So it looks like we're going to get 300 feet, in this case square feet, for that triangle. Now I want to find the total area, so I have to add these together. So the total area of this figure is 300 plus 300, which is going to give us then 600 square feet for the total area. Now it's time to check your understanding of using a formula to find the area of rectangles and triangles. Pause your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 2. Find the area of the rectangle. Well, to find the area of a rectangle, start with our formula. We need to know the length, so we can multiply it times the width. Let's see. The length of our rectangle there is 10 feet, and the width is 5 feet. So we're going to multiply 10 times 5, which is going to give us 50. And now we want to make sure that we're indicating this is a measure of area. So we write 50 square feet. Question 3. Find the area of the entire figure by adding the area of the two figures that make it. Well, let's start with the area of the rectangle. Area of the rectangle is length times width. The length of our rectangle is 30. The width is 20. So I'm going to multiply those two together. 3 times 2 is 6. And then I have 1, 2, 0. So I just add those two zeros. So that would give me 600 square feet for the area of the rectangle. Now let's take a look at that triangle. But again, in this triangle, we have some information that is missing. So we need to know both the base and the height of that triangle. Let's take a look at the base. If the bottom here is 30 feet, we bring that measure straight up in this rectangle. That means the bottom of that triangle also has to be 30 feet. Now the height, notice this distance to here is 20 feet. The whole thing is 40 feet. That means this distance here must be 20 feet. So the height of that rectangle is going to be 20 feet. So now let's go ahead and calculate its area. 1/2 base times height. So 1/2, the base in this case is 30 feet. The height is 20 feet. 1/2 of 30 is 15. And we're going to multiply that times 20. So we'll come over on some scratch work. And we'll do 20 times 15. 5 times 0 is 0. 5 times 2 is 10. Carry the 1, which would just bring it down. It'd be 100. Then 1 times 20, 0, 2. Add that up. We're going to get 300. So the area of that triangle is 300 square feet. Now, to find the area of this all together, we need now to find the total area. We're going to add these two measures together. So let's see, one we had 600 feet, the other we had 300 feet. Add those together, we're going to get 900, and that is square feet. We also have formulas to find the area of parallelograms and trapezoids. Start by looking at our formula for finding area for a parallelogram. The area of a parallelogram is just base times height. But again, with the base and the height, we want to make sure that those measures are perpendicular. So you can see here, there's my base. My height, I want to make sure, makes a 90-degree angle with the base, so I'm measuring straight up and down. I would not use this side to indicate the height of that parallelogram. Taking a look over here at the trapezoid now. The trapezoid, we want to consider two bases. In this case, we have the smaller one, which we use with a lowercase b, and the larger base, which we indicate with the uppercase b. And again, the height, we want to make sure that that height makes a 90-degree angle with the bases. Now, if we take a look at our formula here, for the area of a trapezoid, we take 1/2 of, and then we take the two bases and add them together. We take 1/2 of that, and then we multiply that times the height. Now let's take a look at some examples that will help you understand how to find the area of a parallelogram and the area of a trapezoid. Example 4. What is the area of the figure? Well, in this case, we have a trapezoid because we have two parallel sides, and so we want to find the area then of a parallelogram. And so the area of a parallelogram, all we do is we take the base times the height. So the area then, in this case, the base is 12, and we are going to multiply that times the height, which is 8. So we're going to take 12 times 8 to give us this area. Let's go off on some scratch work. Multiply 12 times 8. So we'd say 8 times 2 is 16, carry the 1. 8 times 1 is 8, plus 1 more is 9. So we get 96, and now we want to indicate that this is a measure of area. Notice we were measuring with centimeters there. So we want to write square centimeters or centimeters to the second power. Example 5. What is the area of the figure? Well, in this case, we only have one set of parallel sides. So this figure is a trapezoid. And so we want to use the formula for finding the area of a trapezoid, which is 1/2 the two bases added together, and we're going to multiply that then times the height. So let's take a look. 1/2, we're going to multiply that. Let's take a look at these two bases. One of these bases is 6 yards. The other base is 12 yards. So I'm going to have 6 plus 12. The height is 2. So I'm going to multiply outside here by 2. Now we're going to follow the order of operations, which tells us to get an answer inside of these parentheses first. So I'm going to add those two bases together. 6 plus 12 is 18 times 2. Now I'm going to multiply 1/2 times 18. All that is going to do is find half of 18. Well, half of 18 is 9. So I have 9 times 2. 9 times 2 is 18. So that's the area. Notice I was working with yards here. So I want to make sure that I write my answer in square yards. Now it's time to check your understanding of finding the area of a parallelogram and a trapezoid. Pause your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 4. What is the area of the figure? Well, in this case we have a parallelogram because we have two parallel sides. So to find the area of a parallelogram, we take base times height. In this case, the base is 14. The height is 9. So we're going to multiply 14 times 9, so we come off on some scratch work. Multiply this together. 9 times 4 is 36. Carry the 3. 9 times 1 is 9, plus 3 is 12. So we get 126. And now notice I was measuring this in meters, so I want to make sure that this is a measure of area, so I want to write meters squared. Question 5. What is the area of the figure? Well, here we have just one set of parallel sides, so this figure is a trapezoid. So we're going to write down the formula for the area of a trapezoid. 1/2 of, and we're going to have these two bases that we're adding together, and then we're going to multiply it by the height. Okay, so let's put some of this information in. One of my bases is 6 feet, the other is 14. So I would say 6 plus 14, and the height in this case is 4 feet, so I'm going to multiply by 4. And again, we want to follow the order of operations, so I'm going to add together what's inside the parentheses. And when I add 6 and 14 together, I get 20. Now I need to multiply. Well, multiplying 1/2 times 20, all I'm going to do is take half of 20. Half of 20 is 10, and I'm going to multiply that times 4. 10 times 4 is 40, and now I want to make sure that I indicate this is an area of measure. A measure of area. So I have to write feet squared, or feet to the second power. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.